This is video number 5 on the topic motion in a straight line. This first video on differentiation. Timestamps are given in the description box. You can watch parts of video if you are running short of time. In this video, I will discuss how a function is represented. First, I'll define what is a function and what is differentiation, how to differentiate a function, what is slope of a curve, and how is it related to the derivative. Geometrical interpretation of derivative is that it is the slope of the curve. A function is the mapping between two variables x and y. So if a function is represented like this, x can be considered as input and the output is y, which is f of x. So the possible values the input can take is called domain, and all the possible values the output can take is called range. So this can also be represented as a mapping between two sets x and y, and one value of x is mapped to a value of y. So this mapping is done by the function. A function can be represented in different forms. It's basically a relation between the two variables x and y. So when x takes some value, for example, y can take value 1. When x takes value 2, it can be 4. This is just an example. x3, y9, and say minus 1. X can be any real number, y is also any real number. 1, minus 2, 4, minus 3, 9. So for given value of x, the value of y is known by using the table. The same information can be represented like this. I have two sets x and y. So value of x will be mapped here corresponding value of y. So according to this one, 1 is mapped to 1, and then 2 to 4, and then 3 to 9. I am representing the same relation using this form, and then minus 1 to 1, minus 2 to 4, and then minus 3 to 9. So this is another way of representing this same information. This information can also be given like this: 1, 1, and then 2, 4, 3, 9, and then minus 1 is mapped to 1. So minus 1, 1, minus 2, 4, and then minus 3, 9. So I'm listing the pairs. First is x, second is y. So this is also another way of representing the relation between x and y. Another way of mentioning this relation is I can plot the value of x on the horizontal axis and the value of y on the vertical axis. So x takes value 1, 2, 3, minus 1, minus 2, minus 3. And the corresponding value of y is 1, 2, 3, 4, 5. Okay, somewhere 9 is there. Okay, we need up to 9. 1, 4, and 9. So this is 4, this is 9. So 1 is mapped to 1, and then 2 to 4, and then 3 to 9. Minus 1 to 1, minus 2 to 4, and then 3 to 9. So we can also represent this function by this sort of a thing, and I can join these points. Actually, this function is y equal to x square. This is the relation between y and x. Okay, so the advantage of this representation is the number of values of x for which the relation is defined is infinite. Because here, if I want the value of y for 1.1, I just have to take this point and find the corresponding value of y. Okay, even for 1.01. So the number of points for which the function can be defined is infinite. But here, if it is 1.1, again I have to give the value. 1.9 is another value. So 2.8 means another value. So the table will become bigger and bigger. Even the number of elements here will become bigger, more, and here the number of pairs will become more. So this is compact or more convenient way of representing the function, which is a curve. And this curve is y equal to f of x. This relation between x and y. In this particular example, the relation is y equal to x square. So these are different ways in which the function can be represented. So given a function, there is the relation between x and y, we can ask another question. When the input changes by a certain amount, say delta x, how much the y will change? For example, if I take one specific function, say y equal to x, so the plot will look like this. Is a straight line. Y equal to x, this is x-axis, this is y-axis. So this is equal to y is basically f of x. So this is the first function. I can have a second function, say another simple function. The relation is y equal to 2x. So this function is second function, f2x. So this is x equal to 1 and this is say x equal to 2. So for the first function, when x takes a value 1, y is 1, and for 2, the value of y is 2. Second function for x equal to 1 is the first function. This is 1 point, this is second point. Second function, the first point is x equal to 1, the corresponding value of y is 2. When x is 2, it will be 4. So this is the second point, the corresponding value of y is 4. So for the two functions, I can find delta y when x is changing from 1 to 2. So when x is changing from 1 to 2, for the first function, the change in y is this much. That's equal to 2 minus 1, 1. So delta y for the first function is 1 for this change of x. For the same change of x, the corresponding change in the y value for the second function is difference between these two, delta y2. Because of the second function x is 1, this is the value of y, and x is 2, the value of y is 4. So these are the 2 points. So the change in the y between these 2 points is 4 minus 2, it is 2. So delta y for the two functions are different for the same delta x. So this information can also be got once the function is defined. So once delta y is known, I can also find one more thing, which is delta y by delta x for the first function and delta y by delta x for the second function. This will be delta y is 1 and the corresponding change in x is 1. Here delta y is 2, corresponding change in x is 1. So this second function is steeper, so the change in the value of y will be more because the same value of x is climbing steeply. So the corresponding change in y will be more for the same change in the value of x. So when x changes by an amount delta x, the change in y is delta y. So if delta x is known, delta y can be found out if the function is defined. And once delta y is known, this ratio delta y x also can be found out. So delta y by delta x, in the limit delta x becomes small, like I took delta x as 1 and 2. Okay, but the second one can be very close to the first point. So this thing is denoted by dx. And the corresponding small change in y will be dy. So when the delta x tends to 0, delta by delta x becomes dy by dx. And dy is the change in y for the small change in x, which is f of x plus delta x minus f of x by delta x. And in the limit you have to put delta x equal to 0. So delta stands for small change and dx stands for very small change. With the limit, it is tending to 0. So for a given function, once the function is defined, we can find du by dx of this function at any point, at all the points. For example, this function y equal to x square, at any point I can go and do a small change in x axis, y axis, dx, and find the corresponding change in y, and find this ratio du by dx will be of some value. Okay, and similarly I can go to this point and find du by dx, will be some other value. Okay, and any point I go and find the value of du by dx, and I can join all these points to get a function which is denoted by f dash, which is based on f. So that function is called derivative of this function f. This function f. This function is just du by dx of this function, which is called f dash, denoted by f dash. So the function which maps x to du by dx, this x and this value is du by dx. Because the y values of this thing is du by dx, is called the derivative of the function f of x and is denoted by f dash x. So f dash x, which is derivative of the function, is mapping between x and du by dx. Once the function is defined, this can be calculated. For example, I showed here for the function y equal to x square. So f dash, which is derivative of the function, is mapping between x and du by dx for a given, or once the function is defined. So derivative of function f dash x, which is du by dx, what is the geometrical interpretation of it? The function is basically a relation between x and y values, which can be given like this. If you put a value of x and once the function is defined, I can calculate and get the value of y. So this can be plotted. I'll take different values of x and find the corresponding y and get different points and join those points, the function curve I'll get. So this function is represented by this blue curve here. Okay, and delta by delta x of this function is defined between 2 points. For example, the 2 points can be P and Q as shown in this graph. First point is x comma y, P. Second point is a little bit far away from it. So the coordinate x coordinate is x plus delta x and y has changed to y plus delta y. So between these 2 points, delta y is this distance and delta x is this distance. Because x coordinate of this is x plus delta x, means the distance from this point to here is x plus delta x. And this one, the distance from here to here is x. That is the meaning of the coordinate. So the distance from here to here is delta x. So this distance is delta x from here to here. Similarly, from here to here is y plus delta y, and from here to here is this one y. So this distance is delta y. So delta y by delta x, this angle is 90 degrees. The angle between x and y axis is 90, and this is parallel to x axis and this is parallel to y axis. So angle between these two is also 90 degrees. So this is a right angle triangle. So delta y by delta x, if this angle is theta, It's a right angle triangle. This will be equal to tan theta. And theta is the angle which this line makes with the x-axis. And this line is a line joining the 2 points of the curve, which is called secant. Like in a circle, a line joining 2 points on the circle is chord. Similarly, for a general curve, a line joining 2 points is secant. So this is equal to slope of secant joining the points P and Q. To define delta y by delta x, we have to define the 2 points for which I am finding this delta y by delta x. Now, if I take this condition that delta x is tending to 0, that means this point is Q is coming closer to point P. So when this point Q comes here, this will be delta x, this will be delta y. But the angle is still the same. Okay, but in the limit, when Q is touching this, when delta x tends to 0, Q will touch this point, come very close to P. So in that case, this secant will touch this curve at only one point. That means secant will become tangent. So secant tends to tangent. So dy by dx is, in this thing you have to put the limit delta x tending to 0. So that will become slope of tangent at point P. So this dy by dx is defined at point P. So it can be defined at any point. So at this point, dy by dx is, you have to draw a tangent here, it's the slope of this tangent. At this point, it is slope of this tangent. Tangent is becoming steeper and steeper. Delta by delta x is defined between 2 points. Dy by dx is defined individual points. So here in pair of points, here it is defined for each point. Single point, you can find dy by dx. So P and Q denote points with coordinates x comma y and x plus delta x comma y plus delta y. So delta y by delta x is slope of the secant which joins the point P and Q. And in the limit delta x tending to 0, the point Q approaches the point P and the secant becomes tangent at point P. Secant is defined between 2 points P and Q. Tangent is defined at any point. Here it is defined at the point P. dy by dx is delta by delta x in the limit delta x tending to 0. This is by definition of dy by dx, which is slope of tangent. And this dy by dx is called the derivative of the function, which is represented as y equal to f of x. So the geometrical interpretation of derivative dy by dx is slope of the tangent. To summarize, the derivative of the function dy by dx is delta by delta x, the limit delta x to 0, and delta y is change in f value, that is y value, at the 2 points where the x coordinate is changing from x to x plus delta x. Geometrical interpretation of delta by delta x is slope of the secant PQ. This is defined between pair of points. Here the pair of points is PQ. And as delta x tends to 0, the point Q approaches point P and the secant tends to tangent. So dy by dx at the point P is delta by delta x in the limit delta x tends to 0, which is slope of tangent. You can ask your doubts in the comment section.